Hey guys, welcome back everyone. So yesterday in the classroom we have discussed about the IBGP of a split horizontal concept, right? So yesterday we have also discussed the how we can prevent the loop in the EBGP. So if you're going to prevent the loop in the EBGP, we are going to use the ACE path information, right? And if I'm going to use the IBGP talk about in the IBGP, what happened? We have a split horizontal, right? So basically what happened by default, these two features are enabled, right? We are not going to enable by default this thing. By default, these features are enabled. And as compared to the RIP protocol and EHGRP, we don't have a command in the IBGP to disable the split horizontal. So what IBGP split horizontal saying that, take example, this is router number one. Okay, this is my router number two, and this is my router number three. Three routers are there. And this router has a connectivity with the physical media, this guy to this guy, router one, router number two, router number three, and this guy has IP address. I can go for this person is 12.1, this guy is 12.2, and this guy is 23.2, and this guy 23.3, right? So this is the 100.0 prefix behind the R1, and this prefix is known as a NLRI information in the BGP terms, right? So guys, what happened? All these routers are running with the same AS number. So we can say the AS number, this guy is going to go for the AS number 123, right? So we'll have a IBGP connection, or IBGP connection is also known as a internal BGP, right? The IBGP connection is known as a internal BGP. So the BGP, IBGP, not BGP, right? So the term is changed IBGP, I'm saying, not the EBGP, sorry, BGP. In IBGP, IBGP split horizon, saying that whenever IBGP router, listen to me, whenever IBGP router receive update, whenever IBGP router receive update, it will never share same update to another IBGP neighbor, but it can share the same update to EBGP. One more thing that I'm going to mention over there, IBGP does not contain ACE path information in update packet that we have discussed yesterday. Right? We have seen that it's this thing, whereas EBGP does contain ACE path information in update packet, right? So basically what happened when R1, try to understand this thing. Right now we all have a BGP configuration. BGP is running on the BGP is running, BGP is running, and BGP is running. So when R1 will send this update to the R2, which update I'm talking about, the 1.0.0. So in this case, what happened? When R1 will send this update to the R2, in this case, what happened? What R2 will do in this case? R2 will inject this information in the BGP table, right? The star is going to represent that it's a valid route, and the less greater than is going to represent the best route, right? So in the BGP table, we have this information 1.0.0 with the next hop will be 12.1, right? With the next hop will be 12.1. But what happened? R2 will never share the same update. One minute. It will never. It will have a share. It will never share the same update to another IB. So R2 will never share the same update to the another IBGP neighbor, because all these guys running with the same AS number, right? AS number 1 to 3, right? R1, R2, R3, same AS number 1 to 3. So R2 will never share the same update to the R3. But in the case if you have a router number 4, that this guy is running with the AS number 4, right? So we have a EBGP connection over there. So in this case, what happened? R2, right? Router number 2 can share this update to the R4. This was the IBGP split horizontal, and this is how we are going to prevent the loop in the IBGP. And another thing is that IBGP does not contain the ACE path information. So the problem is happening over there. What happened? The user that are sitting behind the R1 and the user that are sitting behind us, guys, I'm just recapping the yesterday thing, right? So the user just behind the R1 and the user just behind the R3, they cannot communicate to each other. but the user behind the R2, they can communicate to this person. So to avoid this problem, what we have introduced the concept of full mesh. So in the full mesh, what happened? In the full mesh, what happened? I need to make a neighbor relationship between this guy to this guy. I need to make a neighbor relationship between this guy to this guy. After that, I need to make a indirect neighbor relationship between this guy to this guy. This is the full mesh. So in this case, what happened? R1 can share this update to the R2, which update? This update 1 or 0 or 0 or 0 or 0 or 0. At the same time, R1 can share this update to the this person as well as. So now this update will be exchanged to the R2 as well as and R3 as well as, and we can achieve by using the full mesh. But you know what's the problem is happening in the full mesh? The biggest issue I'm telling you in the full mesh. Let's coming to the diagram. Okay, topology. So right now this guy is running the ACE number 1. So just ignore this point right now. This router number 4. And what I'm going to do, I have a one route over there. This is the 1 or 0 or 0 or 0, right? I want to exchange this information to the R2 and R3. How do I do that? I just need to form the neighbor relationship between this person to this person. And from this guy to this guy, 23.3. And R2 will form the neighborhood of this guy, right? Full mesh configuration I'm going to do in this ACE number 1. So yesterday we have discussed the full mesh. I'm just going to show you the problem. One minute, I need to increase my putty size. Appearance change and I'll go for the 18 is fine for this one, and session default setting, save it. R2, R3. There's R2. So if you just go back to the router number 2, first verify the show IP interface brief. Do we have IP addressing or not? All good. So router number 2 has IP addressing. This guy is a 12.2 and this guy is a 23.2, right? So 12.2 and 23.2 is there. And when we have a loop back, that's behave like a router ID of R2. Come back to the router number 1 and show IP interface brief. We have a one physical interface IP address 12.1 and one we have a loop back. If you go back to the router number 3, show IP interface brief. So one we have a loop back and one we have a physical interface. All good. So let's configure the BGP of it. I said the router BGP number 1, neighbor 12.2 remote edge will be 1, R2 BGP router ID, define the BGP router ID manually. That's always recommendation, guys. I know this will take the highest loop back, but let's configure the manually and make a habit of this thing. 23.3 because R2 will have a two neighborship. One they will have a neighborship with a 12.1 and another neighborship R2 will have a R3. At the same time, just go back to the router number 3 and router BGP number 1 BGP router ID defined manually over there and say that neighbor 23.2 and remote edge will be 1 and just wait for some time. So if you see router number 2 having a two neighborship with the 12.1, that's the R1, and R2 will have a neighborship with the 23.3 as well as. All good. Now, if you just go back to the router number 1, and I'm going to advertise this route, this is the line information 1 or 0 or 0 or 0. What happened? R1 will send the update packet to the R2. R1 will send this update packet to the R2, right? So if you see this update packet, okay, not this one. How is the update? So if you just open the update packet in this network layer reachability information, what happened with the ACE path information is empty over there, right? So 12.1, that's a R1 is sending the update packet to whom? R2, right? So the port number I'm going to use the 179. The complete unicast packet is there, right? Source MAC is also unicast and destination MAC is also unicast because BGP does not going to use multicast address. Now we have a 1.0 information that we have advertised, but what happened? The ACE path is empty over there because IBGP does not contain the ACE path information. So what happened? R2 will receive this information, right? R2 will receive this information, but R2 will never share this information with the R3, or we can say that another IBGP neighbor. Can we have a look over there? So we have 1.0.0 that I'm getting from the 12.1, and we don't have a ACE path information because IBGP does not contain. And this I is just going to represent that this is the IBGP learned route. This is the IBGP learned route. And for the IBGP learned route, what is the AD value? The AD value will be 200. So what about the R3? On a R3, you see, I don't have any information because of the split Trojan rule. So what we have to do, we need to make a full mesh, right? How do I make it full mesh? I need to make a neighbor relationship with the 23.3, remote H1. Then I need to define the static route towards this guy. Need a reachability, right? R3, neighborship I'm going to form with the 12.1, IP route. Done. Now they will form the neighborship. Still, we don't have a route, right? Just wait for some time. It's a slow routing protocol. So once the neighborship has formed, can we have a look over there? R3 is forming the neighborship with this guy, right? And this guy as well as. So this is how the topology look like this. So right now my topology is something like this: R1, sorry, R1, R2, R3, like this. This one, and this one. Full mesh. So now if you see on R3, what happened? I'm able to receive the update, right? From the 12.1, 1.0.0.0. And I'm going to add this update in my routing table as well as RT, routing table, 280 IBGP route. So if you see show IPBGP, this I is going to represent IBGP, right? And I'm getting this route from the home, 12.1. The problem is that, guys, show IP BGP summary R3 is maintaining a two neighborship. So if R3 is going to maintain the two neighborship, as we know that BGP works on the TCP protocol, right? So you will have a two TCP socket. And if you have a two TCP socket, so for each TCP socket, what happened? We have a TCP block. So can you imagine how many information that this router is going to store now? Can you see from here to here, this information, right? All this information is stored by whom? Router number 3. For how many neighbor? One neighbor. And right now, R3 is maintaining how many neighbors? Two neighbor. So what will be the CPU and memory utilization of the router number 3 right now? If you remember in the some lecture, I told you that if the router does not have a much memory, right? If the router does not have a much memory, the user cannot perform any kind of telnet or SSH access. And if the router does not have a much memory, they cannot operate well. The performance of this router will be degraded. So the issue with the full mesh, guys, in just a small topology, right? In just a small topology, how many neighborship R3 is maintaining? Two neighborship. One I'm going to maintain with the 23.2, that's R2. And one I'm going to maintain with the 12.1, that's R1. And for one TCP session, I'm going to maintain this huge information. So can you imagine if you just have a 50 routers, and I'm going to tell you do one thing, make a full mesh over there. How many TCP session will maintain by the router now? N equal to n minus 1 divided by 2. 50 minus 1 divided by 2. इसको निकाल लेना यार, लो। Can you imagine how your topology will look like this? Hey guys, this is all over the TCP. What about the running config now? Your running config is completely full with the only BGP configuration. What do you think? BGP has only, router has only work with the BGP. No, router has a different work. Router has the ability to perform the MPLS connection. Router has the ability to perform the encryption and decryption IPsec. They have the ability to perform the GET VPN as well as SLA, NTP, routing protocols, lots of the things. They are not interested only for the dedicated for the BGP. Router is not only dedicated for the BGP, they have a different work. And if you're just going to implement the full mesh, you will have a lots of disadvantage. So to avoid the full mesh, what we have introduced the concept of route reflector. The another way to disable the split horizon route. This is the another way to disable the split horizon route. And how this route reflector is going to work, guys? You just need to understand this concept. Can you see what happened when the light, right? When this light is hitting on this surface, what happened? They will just reflect this light to the different direction. When this light is hitting on this surface, what happened? They will just reflect this light to the different direction. That is the concept of light reflection, right? Same thing the route reflector is going to do. Same thing the route reflector is going to do. In the route reflector, what happened? Once the router one, for example, in a route reflector, what happened? We have a three types of component. But first we have a server. Second, we have a client. And third, we have a non-client. So it's totally behave like a client and server model. So if you remember, we have in a client and server model, what happened? We have a one server over there, right? And we have a multiple clients. All right. So what server is going to do? If server is going to receive any kind of information, right? If server is going to receive any kind of information, they will just flood this information to all client. If server is receiving any kind of information, they will just flood this information to the all client. Same thing route reflector is going to do. What I'm going to do, I'm just going to make this guy as a reflector. Or we can say that this guy is a server. And this guy will become a client. And this guy will become the client. So in this case, what happened? Try to understand. Always you will choose a router as centralized router as a server. I'm again repeating, always you will choose a centralized router as a server. You can also choose this guy as a server, but try to understand what is the use of reflector. Reflect the information, right? Reflect the information. So if R1 will send the own information to the R2, try to understand. If R1 will send this information to R2, R2 is behave like a what? Server, or we can say the reflector. It will just reflect the route information to the another client. So tell me how many neighborship I'm maintaining over there. R1 is just going to maintain the neighborship with the this person. That's it. So if somebody, this is the most important interview questions, guys. If somebody will ask you, hey, tell me how do I reduce the TCP session? How we can reduce the TCP session in BGP? How we can reduce the TCP session in the BGP? There's only one concept that is known as a route reflector. Route reflector is the way that reduce the TCP session in the BGP. Is only one way. So in this case, what happened? I just need to every router. If you have a 50 routers over there, if you have 50 routers, in a 50 routers, so what happened? Every single client is going to make a relationship with the server. Every single client. We are just avoiding the full mesh configuration by using a route reflector concept. I'm just going to make a one dedicated server over there, right? R2. And what server is going to do? Whenever server will receive any information, it just reflects this information to the R3, or we can say the client. So in this case, what happened? R1 is just going to maintain the neighborship with R2, and R3 is also going to maintain the neighborship with the R2. That's it. We don't have a neighborship between this guy to this guy. Exactly, you can make it backup reflector as well. As if the primary reflector goes down, you can make it backup. Same thing if R3, take example, if R3 has a 3.0.0.0.0, R3 will share this information to whom? Server. And what server will do? It will reflect this information to the this guy. So but there is no command. There's no command to make a router as a server. You have to assume, hey, this network engineer has to assume this is my server router. There's no command. There's no command to make this router as a server. You have to assume, hey, you are my server. So on our server side, you have to go and tell this person, hey, you are my client and you are my client. So client will just send the information to the server, and server will just reflect the information to the another client. So if you just have a look, what I can do right now, I'm going to remove this neighborship right now. And first I'm going to remove the this route and on R3 as well as this route, and as well as on R1, I'm going to say router BGP number 1, no need, no neighbor. I'm going to remove the neighborship with the 23.3, right? 1, 12 around. So now we just have a single neighborship. Can you see? We just have a single neighborship with the 23.2. So R3 is forming the neighborship with the 23.2, that's the R2, and R1 is also going to form the neighborship with the 23.2. Sorry, 12.1. Sorry, it's 12.2. R2. What I'm going to do over there, guys, right now, if you see on R3, we don't have this information. So I BGP. This information is only present on R2. R2 will never share this information to R3. Never. Just because of the IBGP split horizon rule. But on R2, we have this information. What I can do, I'm just going to assume R2 is my server. So now R2 router, I'm just going to say a neighbor 12.1. Hey, you are my client. You are my client. Once I put this command, your neighborship will be reset, right? All the three-way handshake will process again. If you see, you can see. Now again, I need to configure the same this guy. Let me capture this link as well as. And again on R2, I'm going to say neighbor, hey my neighbor 23.3, you are my client. So I'm just going to router number 2. I'm just going to define this command on a router number 2. Once I'm going to define on a router number 2 this command, what router number 2 is behave like, hey, I'm now server. You are my client and you are my client, so I'm your server. So sync plus acknowledge will happen, right? Three-way handshake is completed. Now, if you just go back to the router number 1, if you see on a router number 1, we just have a single neighborship with the R2 only. With the R2 only, right? But if you go back to the router number 3, we only have this information, right? So I will give summary R2. But what having on R3, we have this information in my BGP table. What R2 is doing over there, when R1 is sending this update to the R2, R2 is behind a server, right? And what R2 will do, they will just send this information to the client. They will just reflect this information to the client. But do you know the what's the problem is happening over there? By default, most important, most troubleshooting steps. By default, IBGP does not change next hop. By default, eBGP does change next hop. What's the meaning of that? R1, R2, R3, R1, R2, R3. So if you have 1.0.0.0.0 slash 8 route behind the R1, and if you have 1.0.0 slash 8 route behind the R1, this is my AS number 1 IBGP, and this is ABGP. So when R1 will send this update to the R2, what happened in this case? 1.0.0.0.0.0.1 next hop. When R2 will send this update to the R3, 1.0.0.0.12.1 still next hop. So in the R3 BGP table, we have this information. In IBGP does not change the next hop. When R2 will send this update to the R3, never change the next hop. But when R1 will send the update to the R2, next hop will be 12.1. But when R2 will send this update to the R3, the next hop will be 23.2 because R2 will modify the next hop. That's why saying that by default, eBGP does change the next hop. Now the question is that what is the problem is happening in the next hop? Hey guys, whenever Attribute. One of the part attributes we have a AS path information that we have seen. We have a next hop as well as. What is the rule of next hop? What is the role of next hop over there? So whenever the BGP router it verify the next hop reachability. If the next hop is not reachable, if the next hop is not reachable, and if the route, why? So right now, what happening over there, guys? If you just have a look, IBGP does not change the next hop, right? So when R1 is sending the update to the R2, what is the next hop is happening? 12.1, right? But when R2 will send the update to the R3, what is the next hop? Still 12.1. So what R3 is saying that my next hop is 12.1. Can I ping the 12.1 right now? No, I can't ping. So right now, if you see, this route is just a valid. And if the route is valid, if the route is just a valid route, I'm going to put this route in my BGP table, but I'm not going to install in my routing table. And if the route is not there in the routing table, do we have a 1.0.0.0? No. If the route is not present in your routing table, how does you send the traffic? Because router will send the traffic through the routing table, not through the BGP table. This is just a valid route, not a best. Why this route is not best? Because next hop is not reachable from R3. IBGP does not change the next hop. And that's why this route is not a valid route. So if you see somewhere, this massive will be there. What happened? I'm receiving the update from the 23.2, R3 saying that, this R3 saying that I'm receiving the update from 23.2. That is actually a R2. What is the next hop is happening? 12.1. Hey dude, can I reach this guy 12.1? No, no valid path for 1.0.0/8. Because for this information that I'm receiving from the 23.2, that has a next hop, this guy. And that is not a valid path. If the valid path is not there, no chance to make this route as the best. It's just not valid. And valid route never will be installed in the routing table. So what we have to do in this case, we just need to provide the reachability to the next hop. That's it. 23.2. Now can I ping this guy? Packet will be not there, right? I can send my ICMP traffic. I can send my ICMP echo request packet, right? So if the now the reachability is there, right? So we can have this information. I can send my ICMP traffic. You see, I'll just go back to the router number 1. You see, I'm able to receive the packet, right? From R3. So that's why what happened now, we have a information of the 12.1 in my routing table. Do show IP route. If you see, do show IP BGP. Now the next hop is reachable, right? Because this next hop information is present in my routing table. So if the next hop is present in my routing table, now this is the valid and best route. and I'm going to install this valid and restore in my routing table as well. BGP table and routing table as well. How many seconds ago? Just 1 minute. If you don't define the route from this side, you can define it, no issue, right? Then of course we can ping it. Now can I ping this guy now? Of course, 100% I can ping. All good. Now the user that are sitting behind the R1 and the user that are sitting behind the R3, they can communicate to each other. This is how your route reflector is going to work, guys. I'm again repeating, I'm not done. We have a loop prevention mechanism as well as in route reflector. And we have a loop prevention mechanism in the route reflector. At the same time, we have a rule of a route reflector as well. I'm just giving the overview how the route reflector is working. How the route reflector is working. I'm just giving that information right now. 1 minute. My system is fucking heavy. Hey guys, do you have any questions? Anyone? Not working. Fine. Hello?